Folks, how you doing? We're on page 306. Still working on reflections. Let's hop right into it.
Let's get into it.
Good news. The first question is literally identical to the question in 6.1. How does a reflection affect properties of a 2D figure? Okay? So guys, some things stay the same, some things change. So I'm going to write on here, same, change. So what properties should stay the same when we reflect? What properties change? Somebody said something out there. It keeps the same shape and the same size, but what does change? Right? Yes, orientation, and there's one other, of course the easier one, and that is location or position. Okay? So these stay the same, those change. Awesome. Okay? What do you notice about corresponding coordinates of the pre-image and image after we reflect across the x-axis? So in other words, if we reflect across the x-axis, something's going to stay the same, something will change when we're talking about our coordinates. Right? Like look guys, if we were right here, here's my x-axis. If I were to take this point H and I reflect it, it's going to reflect down here. Right? What stays the same? Is it the x-coordinate or is it the y-coordinate? Any guesses? Okay. So the x is the same. The y, guys, just really turns to its opposite.
Yep.
Okay? So like if the y was at -5, it would reflect a +5. Okay, and the x value stays the same. All right, so good stuff there. You guys want to do question 3 now? Sure, we can. It's all the way down there. Wow, like it. George said the y values would stay the same when you reflect a pre-image across the line y = 5. Again, not a great line to reflect across, but we'll be able to do that. Is our friend correct? So if we reflect across y = 5, guys, that's this line here. Right? Let's say I reflected this blue image across this line here. Are my y values going to stay the same? Absolutely not. Right? Absolutely not. If we look at this point up here, if I reflect it over here, it's, you know what? The x value would stay the same, but this y value is going to change. Okay? So yeah, our friend George, he not right. Okay? That's all right. So you guys can write that in there if you want. Due to time constraints, I'm not going to.
We're not limited on time.
That's right. That's right. Is triangle x prime, y prime, z prime? Do I sound like the thing? Yeah. A reflection of this one. Well, this one's kind of weird. First off, it's not on a coordinate grid, and it's kind of tilted here on a diagonal. All right. So here's what we would look for, though. I want to look. Hey. Is this distance from y to y prime, is this distance the same? Right? If you guys want me to, I can get Mr. Knowles' ruler out here, right? And we could measure these, right? But I need these two distances to be identical. Do they look like they are? They do, right? And indeed they are. So is this a reflection? We would say yes, absolutely, right? The distance from z to the line of reflection is the same as it is from z prime to the line of reflection. Okay?
That's right.
I mean, it seems pretty fair. Okay. Describe the reflection. So pre-image, image, right? Which one's which? Here's your pre-image. Here's your image because it's got the prime marks. I want to describe the reflection. So let's find the line of reflection. Okay? Pick any 2 points you want. E, E prime. F, F prime. G, G prime. H, and H prime. Figure out the middle point between them. Okay? Let's see. 1, 2, 3, 4, 5. So there's 6, squares between them. So 3 would be halfway. 1, 2, 3. 3. There we go. Let's try H. 1, 2, 3, 4. So 2 squares would be between them. Look, here we go. Bam. Right there. Now, we have to name that line. Okay.
Jeremy.
Yes, we can name it. We'll call it line J null, but then we'll name it mathematically. How do we figure out what the equation for this line is? It's really easy. You just got to answer my two questions. What axis does it go through? You're right, it goes through the y-axis. What number does it go through? There you go. That's how we name our line of reflection, y equals 4. What axis does it go through? What number does it go through? Got it.
Got it.
Number 6, last one. Draw the image that would result from a reflection of figure EFGH, so the red one, across x equals -1. Ooh, fancy. Okay, x equals -1. Put a dot on -1 on the x-axis. Okay, draw a line that goes through that axis. Just like so. Okay, now reflect it. So h is 1 spot away. It'll be 1 spot away down here, h prime. G, 1, 2, 3 spots away, or 3 units away. 1, 2, 3. Here's G prime. F, 1, 2, 3, 4. 1, 2, 3. I am good at counting, Mr. Null.
This guy's good.
E, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, and 7. E prime. Now, these figures kind of get confusing. So if you need to, all right, go H to G, G to F, F to E, right? And then E back to H. Okay? There we go. So there's our image after we did our rotation. So hopefully these are becoming a little bit easier for you guys to realize. I know the naming of the lines of reflection is kind of annoying. We'll get better at that because we're going to do a whole bunch of these. But there you go. Stay tuned. I think Mr. Knoll's up next. See ya.